Measuring acceleration, right? We're going to use this formula. V squared is u squared plus 2as. Okay, the one you've derived already. So we need to get the initial velocity, u, the final velocity, v, and the displacement, s, and that will allow us to get the acceleration. So, very similar. We're going to use our rider and card and gate 1 to get the initial velocity. We're going to use our rider and card and gate 2 to get the final velocity. The distance between the initial velocity and the final velocity is hopefully quite obviously the distance between the gates, usually a meter stick. Okay, and the timer, okay, as before, we'll be measuring the timer. I'm resetting the timer there. Okay. Now, how do we get it to accelerate? Many ways, but we'll do this method. We have a string around a pulley, and we have weights, known weights here. The weights, so the force here, force down, which is the weight of the pan and contents, okay, is equal to the tension in the string, and the tension of the string is applying a force to the right. At the moment, the frictional force, because we don't have the air track turned on, is applying an equal and opposite force to the left. There is no force, no net force, and therefore from Newton's second law, the object remains at rest. When we remove the frictional force, there will be a net force to the right, and the object will accelerate, or we can measure the acceleration. So effectively, all I have to do is turn on the air track. And it does the rest itself pretty clearly, so it's pretty dramatic, pretty quick and sorted. Okay, so here we go. And there you go, stopped. Okay, so what we have to do now is we have to take note of the initial and the final velocities. Let's see here. Okay, so the initial velocity and the final velocity. Initial velocity are being 0.069 and the final velocity being 0.171 meters per second. I have the gates the wrong way around on that. Okay, and then I have to measure the distance between the two of these. So from the end of one to the end of the other. Okay, so we're ending up here with a value of about 68.8 centimeters. And then just fill it into that, and I have the acceleration, and we're done.